We are talking about identifying similar triangles using AA similarity postulate and the SSS and SAS similarity theorems. And we want to use similar triangles to solve problems. So in this case, we have 6 examples, and the question is, are the triangles similar? How do you know? And then write the triangle similarity statement. So first thing is we have to look at, are we given any angles or are we given any sides? And in this case, we are given 2 angles specifically. So angle T is congruent to angle R. And the reason that is given. So I'm going to mark this one with 2 and mark this one with 2 as well. And now hopefully we're pretty familiar with this, but we should be able to see that there's another angle, and it's this angle right here. And the reason that we can mark that is because of vertical angles. So now we have angle, we have 2 angles marked on each triangle, so then that does make them similar. So we have to name this angle correctly. So 2, 1, 0. So that's how we're going to name this triangle. 2 congruent marks, 1 congruent mark, 0 congruent mark. So where there's 2 congruent marks, that's angle T or vertex T. So we can say angle TGP is congruent to angle, and we want to go 2, 1, 0 the same way we went 2, 1, 0. So 2 is going to be angle RGS, and that is by vertical angles. So once we have that stated, now we can say that the 2 triangles are similar, and we can basically use our angle measurement name. The only thing we have to change is we have to change it to a triangle shape. So triangle TGP is similar to triangle RGS, and we say by angle similarity, and we leave the similarity symbol. I'm going to get example 2, and the next thing we want to decide is, are we given any sides or any angles? And in this case, we are given 3 sides. So we want to set up an extended proportion. And basically, we just want to make sure we compare big to big, medium to medium, and small to small. So this is going to be the large triangle and the small triangle. So what is the biggest side? On the large triangle, we have 4, 6, 8. So 8 is the biggest. And what's the biggest over here? 6, 3, 5. So we want to compare big to big. Next, we have our next largest side is 6, and that's going to be on the large line. And here we have 5. And then we have 4 compared to 3. So we can type this in our calculator, and we get 8 divided by 6. That is 1.3 repeating. And 6 divided by 5 is 1.2. And 4 divided by 3 is 1.3 repeating. So 2 of them are equal, but that third ratio is not equal. So because not all 3 are equal, that means that these triangles are not similar. They have to have a scale factor that would be matched for each one of those. Then we can look at example 3 and 4. And again, we want to look at it and say what is given. And in this case, we have two angles. We have 68, 68, 63, and 52. Now, we're not given the same angles because obviously 52 and 63 are not congruent. But we can use the values we know to calculate the remaining side. So here we have 68 is congruent to 68. And now we want to check and see if maybe R and B are congruent. So in order to get the measurement of R, we know that triangle sum theorem says that all three angles added together is equal to 180 degrees. So take 180 and we can subtract 68 and we can subtract 52 and we can see what we have left, and that ends up being 60 degrees there. So 60 degrees is not equal to 63 degrees. So these two triangles are not similar. Now we have another example here, and example 4, and we're not given any angles. So again, we're going to have to pay attention to sides, and we want to set up our extended proportion. And then hopefully we can all see that there is a little triangle right there, and then there's a big triangle that kind of engulfs that little triangle. So I know this drawing is kind of deceiving because it says that this dimension from here to here is 7, and this dimension from here to here is 63. So that means that the whole dimension from for this left side here, or the full triangle, is going to be 7 plus 63, which is equal to 70. So 70 is the dimension there along that side. So we want to compare corresponding sides. We have to do one more calculation. We're given 81 and 90, but we're not given the short side here. So 90 minus 81, and that's going to be equal to 9. So now I think we have all of our measurements we need. And again, we want to say big to big and small to small. So we can say 90 is the largest side. Is the largest side of the large triangle. And we have 5, 7, and 9. So 9 has to work here, or it won't work at all. Then we have 7 compared to 70. So 70 over 7. And then we have 5 and 50, or 50 over 5. And then hopefully we're able to see that 50 divided by 5 is 10. 70 divided by 7 is 10. And 90 divided by 9 is 10. So these are all equal. And so we can make our triangle similarity statement. So triangle WGF So WGF is similar to WUV. And that would be by side, 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 similarity. We have two left to check on. And so in example 5, we're given two pairs of sides. We don't really know what that last side is. And then we're also have them share, both triangles share H. So that's going to be another vertical angle. So we can say G8 angle GHF is congruent. Now, this one might be hard to decide if G goes with a J or if G goes with I. And one thing you can compare is G to H is the bigger side. So, which is the bigger side? So it's got to be J to H. So, triangle JHI. And the reason is vertical angles. And now we got to check our proportionality of the two given sides. So I'm going to set up my proportion, and we want to compare the sides. So the two largest sides are going to be 16 and 4. And we were already given the angles here. And then we have 3 and 12. So in our calculations, we have 16 divided by 4. That is equal to 4. And then we have 12 divided by 3, and that is also equal to 4. So triangle, and we can use the way that we named that angle up there. Triangle GHF is similar to triangle JHI by side, angle, side, similarity. In our last example, we have, so that was triangle GHF is similar to triangle JHI by side, angle, side, similarity. We have our last example here, and the only information that we're given is that those two lines are parallel. And so, again, we can use our vertical angles right here. So we can say angle WXV is congruent to angle YXZ, and that's by vertical angles. And next thing we have to check for is, actually, there's a lot of things that we could check for. Angle V is congruent to angle Z. If we have two parallel lines cut by transversal, alternate interior angles are congruent. So we can say this is supposed to be WXV right here. I'm not sure if I said V or wrote V, but that should be WXV is congruent to YXZ. And then another one we can use is we could say angle V is congruent to angle Z by alternate interior angles. The same reasoning as alternate interior angles. We could say angle W is congruent to angle Y, but we don't have to because we already have two angles. So now we can say triangle WXV is similar to triangle YXZ by angle similarity. So we have an angle here, and then we have an angle here. We could actually choose whichever other one we wanted.